We are on the Sea of Marmara, the exact spot where the massive continents of Europe and Asia meet. It's a vital, beautiful waterway packed with cargo ships on the surface, but dive underneath and you'll find a geographical nightmare lying on the seafloor. Deep underwater, two massive slabs of the Earth's crust are violently grinding past each other. This isn't just a minor crack in the dirt, it's a colossal geological fault. A massive complex system of continuous fractures that has been accumulating a devastating amount of energy for decades. We call it the Great North Anatolian Fault. All this energy has to be unleashed someday. And when it happens, it's going to hit one of the most densely populated areas on our planet. Scientists are now in active monitoring mode, especially when it comes to Turkey. This country is sitting on the Anatolian Plate, a small bite of the Earth's crust. Nowadays, it's being literally smashed by the Arabian Plate from the south and the Eurasian Plate from the north. Because it's being squeezed so hard, the only direction it can move is west toward the Aegean Sea, and it actually does this at a speed of about 1 inch per year. In geological terms, that's a high-speed, violent movement. Millions of tons of solid rock grinding against each other deep underground day and night without a single break? Not the best thing to experience. All this endless moving, cracking, and squeezing is what creates the North Anatolian Fault, a 930-mile-long fault line that acts almost exactly like the infamous San Andreas Fault. Yet the difference is striking. While the San Andreas mostly skirts the outer edges of Californian megacities or runs through less dense regions, the fault in Turkey is running right under major industrial hubs and heavily populated urban centers. In February 2023, the smaller sister of it, the East Anatolian Fault, showed us how dangerous this tectonic setup can be. It generated the most catastrophic earthquake recorded in Turkey in over 60 years. A brutal 7.8 monster hit and a 7.5 shockwave followed right behind it just hours later. The release of energy was so violent that the ground literally moved by almost 10 feet in some places. Entire cities were leveled and the physical map of the region permanently shifted. Now the worst part, it wasn't even the grand finale. There's no way to stop that energy packed inside the North Anatolian Faults. Look at the old data and you'll see it acts like clockwork, a bit like a line of falling dominoes. Scientists have been tracking every sequence of earthquakes in this region for nearly a century. The whole chain reaction started in 1939 with the catastrophic Erzincan earthquake. A massive magnitude 7.8 struck eastern Turkey. It didn't simply release the energy, but also transferred this tectonic stress into the next section of the fault. Dominoes started falling. Other fault ruptured happened in 1942, 1943, and 1944. It went west and struck again in 1957 and 1967. Year by year, the epicenters of these massive earthquakes moved in a straight line toward the Sea of Marmara. The last major impact was the Izmit earthquake in 1999. A magnitude 7.6 tremor struck east of Istanbul and lasted for 37 terrifying seconds. Suddenly, the chain reaction took a break, but the tectonic stress was still there, simply transferred to the next section of the fault, under the Sea of Marmara, where the last major earthquake took place in 1766. Nobody had seismographs back then, but historical records and old journals describe it as a scene of unimaginable horror. Now, modern science tells us exactly why it was so devastating. Scientists are calling it a seismic gap, basically a dangerously quiet zone that hasn't ruptured yet. Back then, 260 years ago, a massive quake destroyed a huge part of Istanbul and generated a tsunami that crashed into the city's ports. After this tragedy, it didn't happen again on this scale, but we have to remember that the Anatolian Plate has never stopped moving west, an inch a year. Let's do some quick math. That land should have moved by over 19 feet by now. But because those rocks are locked together, they haven't moved an inch. We are looking at a massive backlog of tectonic tension. It simply has to snap finally, and it won't make a regular shake. It will likely rapidly release 2.5 centuries of accumulated tectonic energy, right at the doorstep of Europe and Asia. The target is the city of Istanbul once again. We should call it a supercity because this global mega hub is home to an astonishing 15 million people. It accounts for nearly 30% of Turkey's entire economic output. What about the infrastructure? We're talking about 1 million buildings, and an estimated 90,000 of those are at high risk of total collapse in the event of a magnitude 7.5 earthquake. Nowadays, the city has very strict laws for modern buildings. But plenty of urban areas had been built before those regulations were enforced. To make matters worse, many coastal neighborhoods are built on soft, waterlogged soil that acts like a liquid during extreme shaking, multiplying the danger for the residents. Buildings could just sink into quicksand. And there's more. The seafloor of the Marmara Sea isn't flat. There are 3 massive deep underwater holes separated by vast ridges. Why is it important? A stronger earthquake in this area will probably trigger a massive submarine landslide. Plenty of mud and rock collapsing down those underwater canyons would instantly displace massive amounts of water. This would trigger a tsunami, not as tall as mega tsunamis in the open Pacific Ocean, but still highly dangerous. It's estimated that with a 10-foot wall of water, it will be extremely dangerous for this densely populated area. Scientists also claim that it could hit the coastline within 10 minutes. There would be almost no time for a mass evacuation. Here comes modern technology. Engineers are fully aware that this geographical clock is ticking and are fighting back. Essentially, infrastructure is being heavily retrofitted. Also, the mighty bridges crossing the Bosphorus Strait have been reinforced with seismic dampers to absorb extreme shocks. One of the world's largest seismically isolated buildings is located at Sabiha Gökçen International Airport in Istanbul. It's sitting on massive bearings made out of rubber and steel. The absolute art of engineering is the Marmara Tunnel, a massive railway tube that runs directly under the Bosphorus Strait, physically connecting the European and Asian continents underwater. It was built right next to an active fault line, so it had to be designed with flexible earthquake-proof joints. If a megaquake hits and the continents shift, the tunnel will bend and flex like a giant snake rather than snapping in half. Another concern of scientists is the economic aftershock of this rupture. It may affect the entire globe, as the Bosphorus Strait is one of the world's most critical maritime choke points. Every single year, nearly 50,000 ships pass through this narrow waterway, carrying everything that is crucial for the global market: barrels of oil, agricultural goods, and so on. The price of energy and food would go crazy if this shipping line collapses. To buy some precious time, scientists have installed an advanced early warning network on the seafloor of the Marmara Sea. Fiber optic cables and seismometers are constantly listening to the fault. But because the epicenter is located so incredibly close to the city, even this multi-million-dollar system won't give residents enough time to escape. At best, it will provide a maximum of 5 to 7 seconds of warning before the destructive waves hit the city. 5 seconds to shut down gas lines, halt the trains, and brace for the impact. Of course, all this effort won't protect the whole city. Only a fraction will survive. The undeniable conclusion is that the migration of earthquakes isn't just a theory, but a well-documented geographical reality. Scientists estimate that there is a 65% probability of a magnitude 7 or greater earthquake striking the Sea of Marmara region before the year 2030. Now we can see that the rupture in this area isn't just a possibility. It is coming, and it is migrating directly toward the collision point of two continents. Earth has one huge connected global ocean that covers about 71% of the planet's surface. And since it's all water, it could make sense that it's the same height everywhere in the world, right? Strangely, at the Panama Canal, the Pacific Ocean is sitting higher than the Atlantic. And it gets even stranger. In the Indian Ocean, there's a massive gravity low where sea level sits dozens of feet lower than the global average. Let's figure out the mystery of the Pacific Ocean first. The difference in height between it and the Atlantic is, on average, about 8 inches, and that's a carefully measured, long-term difference. We aren't talking about waves or high tides here. The thing is, water expands when it's warm. The Pacific is usually warmer than the Atlantic, so its water kinda takes up more space. Salinity matters too. The Pacific is less salty in many regions. Fresher water is less dense, and less dense water sits a little higher. Then there are currents and winds. Strong trade winds, which are winds that blow from east to west just north and south of the equator, push massive amounts of water westward across the Pacific. That water piles up along continental edges. But probably the most important and unexpected factor is that gravity isn't the same everywhere on Earth. Continents, islands, and even underwater mountain chains pull on the ocean's surface. And the ocean actually follows Earth's uneven gravity field, not its geometric shape. Because of all this, global sea level can vary by up to 10 feet from one region to another. Now imagine how difficult it was to fight gravity and build a canal connecting these two oceans. Engineers had to consider the Pacific-Atlantic height difference while working on the construction of the Panama Canal. Surprisingly, it turned out that it wasn't the main obstacle. There were much bigger problems, but we'll talk about them a bit later. So one day, people looked at Panama and thought, how hard could it be to dig a canal and connect two oceans? Very hard. The surface of Panama is steep, muddy, rainy, and unstable. So instead of digging in a sandbox, building a canal would be carving a trench through a wet, collapsing mountain. Engineers wanted a sea-level canal cut straight across so ships could cruise through without any locks or lifting. But Panama wouldn't cooperate. Every time workers dug into a hillside, the dirt slid right back down. During the rainy season, rivers flooded everything, burying the equipment. Then workers started getting sick constantly. At the time, scientists didn't fully understand that mosquitoes were spreading diseases, so outbreaks were literally wiping out crews. Thousands of people lost their lives. Eventually, the whole project collapsed, both financially and physically. Years later, the US tried again, but this time they decided to take nature into consideration. Instead of digging straight through at sea level, they built a giant water elevator system. It works like this. Ships enter huge chambers and the gates closed. Next, water fills in and the ships get lifted about 85 feet. That's basically the height of an 8-story building. That's where a huge artificial lake is. The ships cruise across that lake, then get lowered back down on the other side. It's like moving ships over a hill using bathtubs the size of skyscrapers. Anyway, what's the deal with Earth's gravity? Forget the idea that our planet is a perfect ball. Imagine it as a lumpy and spinning potato. The middle bulges out a bit because of the planet's rotation. The crust isn't uniform either. The density below the surface changes constantly. Some areas are heavy and dense, others light and floaty. That's what actually shapes gravity across the planet. Now, it's time for the geoid to enter our story. It's the shape the ocean would have if it were shaped only by Earth's gravity and rotation, with no waves, no winds, and no tides. In other words, if it just floated freely across this lumpy potato. Over dense areas, gravity pulls harder, so the water piles up. Over lighter areas, gravity is weaker, and the water sags. For example, there's a weird spot in the Indian Ocean where gravity is actually weaker than normal. And because of that, the sea level there sits more than 328 feet lower than the surrounding ocean. That's like water dipping down the height of a 30-story building. It forms a massive circular depression covering about 1.2 million square miles. It's officially called the Indian Ocean Geoid Low. Scientists first noticed it in 1948 during a gravity survey from a ship and have been puzzled about this phenomenon for years. Why would Earth's gravity be weaker in one patch of ocean? Finally, researchers think they might have figured it out. Deep under that part of the ocean, huge plumes of hot magma may be rising from the mantle, kind of like slow-mo lava blobs pushing upward from thousands of miles below. These upwellings can shift mass inside the planet, and when mass shifts, gravity shifts too. Lean mass underneath means a slightly weaker pull, and the ocean water sinking lower in that spot. To test the idea, researchers ran massive computer simulations. They basically rewound Earth's history back 140 million years to see how the region evolved. And guess what? Their models point to the breakup of an ancient ocean that no longer exists. Apparently, tectonic plates moved and pieces of crust sank deep into the mantle in that region. They likely disturbed the material below, setting off those magma plumes. So this gravity hole isn't a hole in the water. It's a dent in Earth's gravity field, caused by deep, planet-scale plumbing problems that started millions of years ago. The depression is so extreme that it influences ocean currents, sea level readings, and even satellite paths. That's how strong these mantle processes are, even millions of years after all that tectonic drama. The big question now is, will the Indian Ocean Geoid Low ever go away, or is it here to stay? Scientists aren't 100% sure. It all depends on how the masses inside Earth move around over time. Our planet's mantle isn't solid. It's constantly shifting, rising in plumes and sinking in slabs. These slow and deep motions can either keep the gravity low intact for millions of years or eventually smooth it out. Think of it like a giant slow-moving lava lamp under the ocean. Over a few 100 million years, the blob could shift enough to erase the dip, or not. In any case, the study gives some interesting ideas and might push experts to dig deeper. The older research only modeled sinking cold slabs in the mantle. Now, the simulations include hot, rising magma plumes. They were probably key to forming the low in the first place. But there are also missing pieces in the simulation. For example, the famous Réunion hotspot, a massive mantle plume that erupted around 65 million years ago, forming the Deccan Traps across India. That eruption dumped lava over half of India. It was one of the biggest volcanic events in Earth's history. Without that plume in the simulation, some of the geoid predictions might be off. There are also mismatches between the model and reality. The predicted shape of the Earth's surface doesn't perfectly match actual measurements, especially in the Pacific, Africa, and Eurasia. The researchers say there's about an 80% correlation, which is quite good, but not perfect. Unfortunately, the simulation can't capture every detail yet. The lead researcher explains why. We just don't know exactly what Earth looked like millions of years ago. Plates were shifting, oceans were moving, and continents were crashing into each other, so there's a lot we just don't know. The models can only give us a rough idea of what the past looked like. Still, despite the small errors, the main takeaway is the following. The Indian Ocean Geoid Low is massive and shaped by deep mantle plumes and ancient tectonic events. It might change over the next hundreds of millions of years, or it might stick around. It's also a reminder that Earth is not a perfect smooth ball we like to imagine.
Get ready, because one of the Pacific Ocean's most active volcanoes might blow any minute now. Scientists monitoring axial seamount, a gigantic underwater lava factory just off the coast of Oregon, say it could erupt literally any time between today and early 2026 at the latest. Yes, it's underwater, but don't get tricked by the ocean's cover. This beast is almost 3 times taller than the Empire State Building. This volcano is inflating like a souffle at a Michelin-starred restaurant, and scientists are so excited they will live stream it. Seriously! So here's the thing. This volcano will explode at any moment now because, well, it's inflating fast. Over the past few months, researchers have noticed that the seafloor is literally rising. It's like Axial is doing its best impression of a waterbed filled with molten rock. Scientists call this inflation, which sounds like something you'd complain about after Thanksgiving dinner. But in volcano terms, it means magma is piling up underground, causing the seafloor to bulge like a souffle that's this close to collapsing. Now, an underwater volcanic eruption might not sound so exotic. After all, most volcanic activity on Earth happens under the sea. Believe it or not, there are more than 1 million submarine volcanoes quietly churning lava beneath the waves as you watch this. The ocean floor is Earth's biggest volcanic hotspot. What makes axial seamount so thrilling is that it's under intense scientific surveillance, unlike any other underwater volcano. It's like the star player in a volcanic reality show, with a network of ocean-bottom instruments giving researchers real-time updates on magma movements, seismic tremors, and crust deformation. In fact, Axial Seamount hosts the world's first-ever underwater volcanic laboratory. Scientists have been keeping a constant eye on it since the 1990s, when they installed sensors that now relay live data straight from the seafloor. This kind of monitoring is unheard of elsewhere and has turned Axial into a geological celebrity, one whose behavior we can track with remarkable precision. Besides, Axial is hilariously predictable. It erupts roughly every decade, and right on cue, it's gearing up for another performance. By mid-2024, it had inflated to nearly the same level as before its last eruption, which means the countdown is on. Scientists are so confident in its schedule that they've set up a volcanic advent calendar, waiting for the day when Axial decides to pop. But hold on, Axial Seamount isn't just your average underwater volcano. It's got style, personality, and a geological identity of its own. Now, most underwater volcanoes, called seamounts, tend to look like cones or flattened domes. Axial laughs in the face of tradition with its unfashionably rectangular caldera, a 2-by-5-mile crater that looks like it was designed by a geologist with a ruler and a grudge against curves. Most volcanoes opt for the classic circular look, but Axial, it went full avant-garde. This caldera is punctuated by fissures, vents, lava channels, and mysterious dome-like structures that rise hundreds of feet high. It's like the volcano's wearing a funky geometrical crown instead of the usual rounded hat. What's more, Axial's location is like prime real estate for geological fireworks. It sits right where two major forces collide, literally. First, it's on the Juan de Fuca Ridge, an underwater mountain range formed where two tectonic plates are slowly pulling apart, like a zipper being undone. Second, it's perched atop the Cobb Hotspot, a deep mantle plume that acts like Earth's sneaky magma espresso machine, pumping molten rock from deep inside the planet and fueling a whole chain of seamounts. To put it plainly, it's like the tectonic plates are reluctant dance partners, sliding away from each other, while the Cobb Hotspot acts as the DJ, turning up the heat and keeping the magma party going. This dual influence creates a complex plumbing system inside the volcano, with magma chambers filling, draining, and shifting in ways scientists are still trying to decode. The competition between the spreading plates and upwelling magma is what gives Axial its unique geological fingerprint, and it's also why this volcano keeps surprising us. Now, we said that Axial Summit isn't just a crater. The truth is that inside, the action gets even weirder and cooler, well, hotter, but you get it. Axial hosts black smoker hydrothermal vents, which blast superheated water at temperatures exceeding 700 degrees Fahrenheit. This is no ordinary underwater hot tub. These vents create one of Earth's most extreme environments, where bizarre creatures thrive in total darkness and scalding heat. Giant tube worms, crabs, colonies of bacteria, and even octopuses live off the mineral-rich plumes that gush from these vents, forming ecosystems completely independent from sunlight and photosynthesis. It's like an alien world beneath the waves, thriving off the volcano's fiery breath. These vent communities are crucial to science, not just because they're strange, but because they may resemble the earliest ecosystems on Earth. Some researchers believe life on our planet may have originated in similar deep-sea hydrothermal environments billions of years ago. Studying them could also help us search for life on icy moons, like Europa and Enceladus, where where similar vents might exist beneath their frozen surfaces. When axial erupts, it's like a natural reset button for these communities. The lava wipes everything out, but within months, life comes roaring back. Proof that even in the most hostile environments, real estate is always in demand. For those worrying about tsunamis or coastal disasters, relax. Axial eruptions are the underwater equivalent of a slow cooker. The immense water pressure keeps things chill, well, scalding, but not explosive. So the worst thing that happens is some lava decorates the seafloor, and a few crabs have to find new vents to squat in. This means no massive ash clouds or explosive blasts that could reach the surface. Instead, lava oozes out and spreads across the seafloor, sometimes traveling for miles. But for scientists, this eruption is the golden ticket. Understanding axial patterns could help predict eruptions elsewhere, even on land. Plus, its bizarre ecosystems offer clues about how life might survive on other planets. Not bad for a volcano that mostly just sits around looking rectangular. Still, the volcano's activity can be heard in the form of thousands of small earthquakes every day. Thousands! As if the volcano itself was groaning and creaking, preparing to burst open. Again, we won't feel a thing, but at least they'll help scientists track the magma's movements and the volcano's eruptive cycle. Now, one of the coolest parts of this story is that scientists are preparing to live stream Axial's next eruption for the first time ever. Imagine watching an undersea volcano in action, live, as it's painting the ocean floor with fresh lava. It's like a front row seat to a natural fireworks display, thousands of feet beneath the waves. The livestream will come courtesy of the Ocean Observatory's initiative, which maintains a series of fiber optic cables linking Axial's instruments directly to shore. It's the Wi-Fi of the deep sea, and it's about to broadcast molten rock in HD. And there's another twist. Scientists have noticed a curious pattern in Axial's eruptions. All three of its most recent eruptions, in 1998, 2011, and 2015, happened between January and April, the months when Earth starts moving away from the Sun. So why? Well, it might have something to do with the Moon's gravitational pull. The Moon's orbit causes ocean tides to rise and fall, which changes the pressure on the seafloor and could help nudge the magma chamber to its breaking point. I guess the Moon isn't just a romantic light in the night sky. It might be the ultimate volcanic whisperer. So, one thing's for sure, when Axial goes, it'll be the best documented underwater eruption in history. So, keep your eyes peeled. This is one natural spectacle you won't want to miss. And who knows, if we're lucky, we might even get deep-sea eruption ASMR out of the deal. Now, if you'll excuse me, I'll be refreshing the live feed like it's a Taylor Swift ticket sale. Alright, listen up. One of the greatest threats to humanity comes from large corporations planning to extract minerals from the ocean floor. The point of no return could be reached this year. The ocean could stop breathing in some places, yet some people see no problem in this. Or perhaps they simply refuse to see it. And here's the kind of cheerful news you might hear about it. Many terrestrial resources are depleting, and the demand from major corporations for valuable metals and minerals is growing. The cost of technology is rising. Consumers can't afford to buy laptops and smartphones, and artificial intelligence might slow down the pace of development. But there is a solution: seabed mining. Ooh! The ocean contains so many valuable resources and minerals that there will be enough for everyone. Prices won't rise, progress will accelerate, everyone will be happy, and blah blah blah. What beautiful words. But there are also many risks. Companies want to extract metals from the seafloor and say they will take all the necessary measures to minimize harm to the environment. But they don't know the consequences. Nobody knows, since this seabed mining is an experimental technology. But unfortunately, this may be incredibly destructive. Yes, the shortage of natural resources is a real problem, but we must not solve it by exploiting the ocean. So, what can we do? There will be some suggestions at the end of this video, but for now, let's focus on the problem. So, have you ever heard of dark oxygen? Scientists recently discovered oxygen 2.5 miles beneath the surface of the Pacific Ocean that is produced without light and without photosynthesis. Do you understand what this means? The oxygen we breathe on land is generated by plants, trees, and sea algae through photosynthesis. But it turns out there's another way. In the deepest, darkest parts of the ocean lie strange, potato-shaped metallic lumps called polymetallic nodules. And these unique formations produce oxygen. They likely existed on Earth long before photosynthesis appeared, billions of years ago, which means studying this phenomenon could reveal countless secrets about our planet. Now for the bad news. These nodules contain a large amount of manganese, nickel, cobalt, and copper, which makes them a valuable resource for advanced battery manufacturing. Extracting this material could destroy the oldest chemical processes on Earth and interfere with critical scientific research. Moreover, we still don't know how significant dark oxygen is to the global ecosystem, or what consequences its extraction might cause. At the very least, it could threaten the extinction of all species that rely on dark oxygen to breathe. Now, this is far from the only problem associated with seabed mining. Imagine a massive tanker arriving at a specific location in the ocean, lowering a giant drill or a massive suction tube, similar to a vacuum cleaner, to the seafloor. Workers turn on loud motors. The drill crushes the ocean floor, and the suction tube pulls up sand. The entire process produces a deafening noise that can disrupt echolocation, for example. A blue whale sends a signal to a friend and suddenly hears the deafening roar of a drill. Now imagine the noise caused by dozens of such tankers, hundreds, thousands. How many fish species will be frightened and remain in constant stress? The consequences of this noise pollution are difficult to predict. In addition, seabed mining can pollute the ocean floor with sedimentary deposits. This is an even more serious threat to ocean life. Here's why. A huge pump sucks up massive amounts of sand. On board the ship, the sand is processed. People extract valuable materials, metals, and other useful substances, while all the leftover sand is dumped back into the ocean. Tons of processed sand slowly settle back to the seafloor, falling on the heads of marine creatures. It's like a dust storm or a cloud of dust that stretches for miles. While the residual material is being dumped, giant pumps suck in new tons of sand. Then, after processing, it falls back down. And the cycle continues over and over. In this way, seabed mining can harm not only dark oxygen, but also the regular one that fish breathe through their gills. As they filter water through their gills, they'll also filter sand particles. Unlike humans, they don't have respiratory masks. This is yet another serious blow to the ocean's biodiversity. And don't forget that along with the sand, the pumps may also draw in octopuses, corals, crabs, and other crawling marine creatures. All of them are part of a fragile ecological chain. For example, sea pigs are deep-sea creatures with transparent bodies resembling snails and jellyfish. They're very fragile and can only survive under high pressure. If brought to the surface, they disintegrate. They don't swim but walk along the seafloor and serve a very important role. As scavengers, these animals clean the ocean floor of debris. They are essentially the ocean's janitors. Crabs even use them for transportation and protection from predators. Since sea pigs are toxic, enemies don't approach them, so crabs travel safely on their backs. What will happen if seabed mining pushes these amazing creatures to the brink of extinction? Who will clean the ocean floor of debris and decaying materials? No one knows what consequences the disappearance of these creatures might have. What about corals? Some live from 400 to 4,500 years. Some marine sponges live up to 11,000 years and are among the oldest known living organisms. And yet, we risk destroying this ancient world for the sake of our technology. Imagine a massive tube appearing above your city right now, sucking up everything – houses, roads, streets, villages, people – and then dropping everything back except for metal objects. The streets would turn into a chaotic mess of dust and broken concrete. The same will happen to the seafloor, which is home to countless marine inhabitants. Deep seabed mining could destroy rare species of animals, even ones we don't yet know exist. The ocean floor in some areas has been studied less than the surface of the moon. We have no idea how we might harm nature with such operations. We have rarely mined minerals under such conditions. The technology is highly experimental, and we need all of this for making batteries, powering modern technology, and supporting artificial intelligence. Perhaps it's worth stopping and finding alternative sources. Perhaps we should not destroy our own home. Now, don't worry, we won't end this video on such a grim note. Of course, there's a solution. To address the shortage of necessary metals and minerals, we don't need to destroy the ocean. Think back to the last time you replaced your phone or bought a new microwave. What did you do with the old devices? Did you throw them away? Sell them? Give them to friends? Every day, people discard tons of old electronics. Almost every old TV or computer contains small amounts of copper, nickel, and other elements. So if we collect this unwanted junk, extract the necessary metals and minerals, and reuse them, we can reduce the need for seabed mining. Companies spend millions of dollars building tankers, drilling rigs, and paying engineers. Why wouldn't they spend that money on organizing the collection of valuable metals and recycling old equipment? Every person could mine useful minerals right at home. And there's another solution. In 2026, many technology giants are going to switch to new sodium-ion batteries, which could eliminate the need for deep-sea mining. The thing is, today, battery production relies heavily on lithium. This element is difficult to extract, and working with it produces many chemical byproducts. One of the places where it's mined is the ocean. But the new batteries are much cheaper, essentially composed of the same element as table salt in your kitchen. They last longer and are far safer to use. Sodium-ion batteries are among the most promising technologies in the field of environmentally friendly materials today. Moreover, large corporations can use artificial intelligence to develop effective plans for extracting and replenishing necessary elements. So, don't despair. We are capable of saving the ocean and preserving the lives of millions of its inhabitants, if we choose to do so.
At first, researchers thought their cameras were glitching. It was the only possible thing that could explain the weird view in front of them. Scalding water was blasting upward while cool methane was fizzing out right beside it. Such a combo wasn't supposed to even exist, but it did. Scientists were exploring the ocean floor near Papua New Guinea when they stumbled across a weird deep-sea hotspot. It wasn't like any other hotspot. There, super hot and cool methane-packed gas were bubbling out almost side by side. This almost never happens in nature, so the researchers were pretty shocked. They were cruising around with a deep-diving robot, the Rove Keel 6000, poking around underwater volcanoes in a remote island chain. These volcanoes hide all sorts of strange features, but nobody expected to find a full-on hydrothermal vent just tucked down there. Plus, other research trips had passed through the area before and missed it completely. This time, the robot's cameras lit up the seafloor and revealed a bizarre view: boiling vents and cold gas seeping out of the seabed. They were practically touching each other. As you understand, normally these two things show up in totally different places. Hot hydrothermal vents form when underground water gets cooked by magma and shoots upward, carrying minerals with it. Methane seeps, on the other hand, come from cold, mushy layers of sediment packed with old organic matter. This stuff slowly breaks down and leaks out as gas. But at this spot, the geology created a perfect mashup. Under the volcano sits a thick layer of organic-rich sediment. Magma creeping up from below heats these sediments, but at the same time, it also heats mineral-rich water deeper down. So you get two very different fluids, blazing hot vent water and cooler methane gas. Still, both are traveling upward through the same cracks in the seafloor. When they reach the surface, they escape just inches apart. So you end up with this bizarre little neighborhood where boiling mineral water and chilly methane bubbles are hanging out like best buddies. To ocean scientists, this is like discovering a unicorn that can also fly. It's weird, rare, and super exciting. An even more exciting thing is that right next to those weird hot and cold vents, an entire mini world of creatures has taken over the rocks. The place is packed with huge clusters of deep-sea mussels, long tube worms, little shrimp and amphipods crawling everywhere, and even bright purple sea cucumbers sitting out in the open. The animals are so crowded together that it's hard to even see the rock underneath. Scientists are pretty sure some of these creatures are totally new to science, but they'd need a special trip just to identify everything living there. The strange mix of hot fluids and methane-heavy gas also changes the rocks themselves. The methane down there is super concentrated, while hot water coming from deeper inside the volcano brings chemicals with it. Together, they create unusual reactions underground. Because of this, metals like gold and silver have built up in the rocks, along with elements like arsenic, antimony, and mercury. It's like a chemical time capsule. The rocks show signs of an older, super hot phase when precious metals were forming. Today, the vents are cooler, but still active. Now, even though this deep sea area is rare and full of life, it isn't safe. Mining already happens nearby, and waste from the huge gold mine on Lahir gets dumped into the ocean. On top of that, companies have licenses to explore the seafloor for minerals and gas. All of this puts the fragile vent community in danger because many of the animals here can only survive in these exact conditions. So scientists are urging for more research and strong protection plans before this one-of-a-kind ecosystem is damaged beyond repair. This underwater treasure needs to be saved before industry wipes it out. This discovery, though, isn't the only unique ecosystem we've ever found. In January 2025, a gigantic iceberg named A84, roughly the size of Chicago, cracked off Antarctica's George VI ice shelf. This ice shelf is enormous on its own, stretching about 280 miles from end to end and about 820 feet thick. During the Antarctic summer, which is November through late February, the top of the ice shelf melts and forms long, skinny pools called ribbon lakes. They got that name because they really do look like giant icy ribbons stretched across the surface. Once A84 broke free and drifted off, it exposed part of the seafloor that had been sealed away under the ice for who knows how long. It was a place absolutely nobody had seen before. A research team aboard the ship Falkor 2 happened to be in the Bellingshausen Sea at the time. As soon as they got word about the iceberg breaking loose, they ditched their original plan. This was basically the deep-sea version of flipping over a huge rock in the woods just to see what's living underneath it. For 8 days, the scientists sent down their underwater robot, Sebastian, and explored depths of more than 4,200 feet. Down in that freezing darkness, they discovered a hidden ecosystem packed with life. Huge corals and sponges formed underwater neighborhoods that were absolutely crawling with creatures. They were not just barely alive, they were thriving. So yeah, the scientists expected to find something down there, but they definitely didn't hope to spot a full-on underwater city of ancient life. There were sea anemones that looked like tiny fluffy trees, sea spiders marching around like creatures from other planets, ice fish, octopuses, and a whole mix of other animals. The entire expedition was live-streamed to researchers around the world. By the way, the recordings are still publicly available if you're interested. Even cooler, the researchers think some of the creatures they saw might actually be brand new species. That's right, genuinely new species in Antarctica in 2025. A few might live only in this one area, and that makes sense because Antarctica is basically its own isolated planet. It's surrounded by the Antarctic Circumpolar Current, which acts like a giant watery moat that has kept the continent cut off from the rest of the world for millions of years. But even if the new species ended up being known ones, the scientists still found some extremely rare animals, like tiny snails, bristly worms, aka polychaetes, little crustaceans, and even the mysterious phantom jellyfish, which already looks like something from outer space. The scientific name for the phantom jelly is Stygiomedusa gigantea, but no one really needs that mouthful, so giant phantom jelly is fine. This thing is massive. Its bell, the umbrella-shaped top, can be more than 3 feet wide. It also has 4 long ribbon-like arms that can stretch up to 33 feet. That's the length of a school bus. Actually, the first one was collected in 1899, but scientists didn't even realize it was a completely new kind of jellyfish until 60 years later. Its body is mostly see-through with a ghostly purple tint, and instead of normal tentacles, it uses those big flowing arms to grab prey and feed itself. Even though jellyfish don't have brains, the way this giant phantom jelly moved caught scientists off guard. It seemed to steer its long arms with surprising control, especially when it drifted through tight spaces near the seafloor. It looked cautious and almost intentional, which is kinda unsettling. Another maybe kinda sorta smart creature lurking in the dark ocean? Great. The researchers also found bristleworms. Officially, they're called polychaetes, but bristleworms sounds way more fun. These worms are common in cold, deep oceans and come in tons of shapes and sizes. Their bodies are made of segments lined with tiny bristles that help them crawl, sense the environment, and defend themselves. One standout is the Antarctic scale worm, which has shiny golden bristles that make it look surprisingly fancy for a creature living in freezing darkness. So, as you see, there are still tons of places and things on Earth that don't seem real or aren't even supposed to exist. And even with our level of technology, we're unlikely to figure out all the wonders the world has to offer in the near future.
Okay, watch your step now. Millions of gallons of hot magma are gathering in one flow and rising thousands of miles to the surface of our planet. A massive fracture in a tectonic plate shakes the ground and fills the air with a loud hum. Fire, gases, lava erupt from the dark, unexplored depths of Earth's crust. A planetary-scale catastrophe has just happened, and no one's noticed it. Now imagine you're having fun on a luxury yacht somewhere in the southwestern Pacific Ocean, drinking cocktails and sunbathing. At this moment, one of the most powerful volcanic eruptions in the planet's history is happening right below you. But you don't feel anything. You don't even drop your glass. Yeah, you can hear a strange sound coming from the ocean depths. You see foaming water and pieces of pumice floating up to the surface. But it doesn't bother you much. So how did it happen that we missed such a powerful eruption in 2012? Why did scientists find out about it only a few years later? The answer is simple: water. An eruption of an ordinary volcano is a huge disaster. There are incandescent liquid metals and molten rock containing almost the entire periodic table inside our planet. All of this soup is called magma, and it's constantly boiling inside the subsoil of our world. This hot substance is lighter than the surrounding crust, so it always rises. Fortunately, the planet's surface is strong enough and doesn't allow magma to splash out. But sometimes this protection fails. The upper part of Earth is covered with connected parts, tectonic plates. These plates collide with each other and then move apart. Imagine a big moving mosaic puzzle where all its parts are tectonic plates. And when a small part of this puzzle gets separated from another, magma immediately comes up. These unstable fault sites with leaking magma are called volcanoes. And when they erupt, it gets hot. Lava flows out of the vent and burns all the vegetation around. This is accompanied by earthquakes and thick black smoke. If a volcano spits out magma too high, it falls back to the surface in the form of fire rain. But the worst thing here is ash. It's not that ash that's left in your grill after a good barbecue, no. Volcanic ash consists of solid particles harmful to any organism. These particles are not burnt wood, but various chemical elements. Volcanic ash is sharp, dense, and tangible. It can block sunlight, cover and destroy all plants, settle in your lungs. If you get too close to an erupting volcano, well, you better have a fireproof suit, oxygen tanks, a gas mask, and an underground shelter. then you might survive, but there's no guarantee. At the same time, if an eruption occurs underwater, you don't need to worry about it. Of course, if you're not a marine biologist studying coral reefs nearby, or if you don't travel past that area in a submarine. In that case, boy, you're in trouble. When an underwater volcano erupts, this shakes a colossal area, heats the water, destroys the seabed. But almost nothing happens at the surface. The enormous pressure of millions of gallons of water suppresses the destructive power of the volcano. Molten rocks shooting out of Earth's crust get pressed against the seabed. Yeah, a submarine swimming by would be thrown off course and might collide with solidified lava. Fortunately, no such cases have ever been recorded, but it can easily become a reality because underwater eruptions happen pretty often. More than 70% of all volcanic activity occurs underwater, and almost no one notices it. In most cases, these volcanoes immediately fall asleep after they erupt and never wake up again. But in 2012, something happened, and scientists couldn't ignore it. Big pieces of pumice, the size of a van, began floating up in the southeastern Pacific Ocean. These rocks covered about 154 square miles. There were thousands of them. They looked like a group of unknown floating mini-islands. Volcanic stones were scattered in the ocean over the area twice as large as New Zealand. Scientists determined the full scale of the disaster with the help of deep-sea sonar devices. They studied the seabed at a depth of 4,000 feet for a long time and found 14 craters from which magma had flowed during the eruption. The seabed was covered with frozen lava flows and tons of ash. The researchers found that more than a third of the erupted volcanic material surfaced and was scattered all over the place. The rest remained at the bottom. This wiped out all marine life in the area. It seemed that this eruption was one of the largest in the entire history of observations. But in 2019, researchers discovered something even more significant. That was an underwater volcano 3 times higher than the Eiffel Tower. According to scientists' calculations, it ejected between 30 and 1,000 times more molten rock than the previous volcano. This monster had been feeding from the world's deepest magma reservoir we know about. Seismic activity here was so devastating that it destroyed everything around. Fortunately, not for long. After any eruption, life reappears like a phoenix rises from the ashes. And it's not just a figure of speech. Volcanic ash and lava around the volcano contain many useful mineral elements. All of them nourish the soil and help microorganisms develop on land and in the water. For this reason, there's usually so much vegetation, flowers, and trees around volcanoes. And underwater volcanoes can eventually form islands. This is a long process that ends with the appearance of a massive piece of land above the water surface. To understand how this happens, you need to go back millions of years. So, let's go. See this underwater volcano? There are sea dinosaurs, giant sharks, and ancient fish swimming around. Now, the seabed starts shaking. The volcano releases tons of magma and ash. The water pressure immediately pushes all this stuff back to the bottom. The eruption can continue for a long time. The released magma raises the seabed. After hundreds, maybe 1,000 years, a new eruption begins. New magma flows create a new layer above the previous one. Over millions of years, layer by layer, the volcano is growing. It's slowly rising, thanks to constant eruptions. Of course, with time, some volcanoes go dormant, but this one continues to erupt. And then, one day, the volcanic rock reaches the surface and an island emerges. After many more years, the volcano can fall asleep. After this, life is likely to appear on the island. Grass, flowers, trees, animals. The area that was once ruined seabed is swarming with life now. Volcanic islands have unique ecosystems because they develop separately from all the continents. Observing such islands helps scientists understand how life on Earth evolves. New species of birds, animals, insects can live on these chunks of land. Hundreds of islands around the world appeared thanks to eruptions of underwater volcanoes. You can find them in Hawaii, Indonesia, Iceland. Many of them are inhabited by people who build villages and towns there. There were cases when a volcano erupted when people literally lived on top of it. That's what happened on the small island of Aogashima, located to the south of Tokyo. People built a beautiful town right in the crater of an active volcano. And in May 1785, an eruption began. Nobody expected this to happen. At some point, Thousands of birds rose in the air and flew away from the island. Then the ground began to shake. A heavy, low sound shook the air. Thick smoke appeared above the top of the green volcano. The crater started spitting dirt, huge rocks, and red-hot pieces of magma into the sky. The disaster lasted several weeks. People somehow managed to evacuate. Then, finally, the volcano calmed down. After that, a long process of recovery started. The inhabitants of the town rebuilt houses, roads, infrastructure. More than 200 years have passed since that moment, and during this time, the volcano never woke up. And despite the risk of a new eruption, people continue living there. The population is growing. Many people from other cities and countries come to live there. The main reason everyone loves this place is that it looks like a paradise. Nobody wants to leave the island. There are thermal springs where you can bathe, dense jungle with many beautiful animals and trees. The soil is rich, and you can grow tasty fruit and vegetables there. The water near the coast is swarming with fish. Every day, you can enjoy the incredible landscapes of the island. Seismological services constantly monitor the situation and watch the volcano's activity, listening for a rumble that may someday come again.
Frankenstein, unreasonably cold weather, and tons of lava. What do these things have in common? They all trace their origins back to Mount Tambora. This volcano in Indonesia had such a massive impact that the aftermath could be felt in Switzerland even a year later. And these spots are thousands of miles apart. Soon, we might be facing something similar again. Stick around, because I'm about to reveal the exact spot where the next eruption is expected to happen in 2025. Back in 1815, Mount Tambora erupted with unprecedented force, sending a colossal cloud of fine particles into the atmosphere. This cloud reflected sunlight, leading to global cooling and even the year without a summer in 1816. Temperatures plummeted, crops failed, and families worldwide faced food shortages, compounded by various health issues. Fun fact: Frankenstein appeared because of abnormally cold weather in the summer of 1816. The author got stuck indoors in Switzerland and wrote this story to pass the time. But that is the only positive aftermath. In England and Ireland, people struggled to find food. The crops were too bad that year, and this year without summer cost them lives, all because of the eruption in Indonesia. While many other volcanoes have erupted since then, none have had consequences as dramatic as Tambora. However, climate professor Marcus Stoffel from the University of Geneva believes potential serious eruptions aren't just a matter of luck, it's only a matter of time. So it's up to us. We can sit back and wait for the inevitable, or we can start preparing today. This future eruption will happen in a world that's vastly different from the one in 1815. Not only is our planet more densely populated now, but we've also experienced irreversible changes that affect our daily lives. Now, if you think volcanoes are always the bad guys, think again. They've actually played a crucial role in shaping our planet. They help with land formation, atmospheric development, and climate modulation. Just look at Yellowstone, for example. When thick lava oozed to the surface, it spread across the landscape and transformed the area forever. When volcanoes blow their tops, they release a mix of lava, ash, and gases, including carbon dioxide. But don't worry, compared to the emissions from fossil fuels, the amount from volcanoes is pretty tiny. What scientists are really keeping an eye on is sulfur dioxide, because it can have a big impact on our climate. When a major volcanic eruption happens, it can send sulfur dioxide soaring into the stratosphere, which is about 7 miles up in the atmosphere. Once there, it transforms into tiny aerosol particles that scatter sunlight, helping to cool the planet. This cooling effect isn't immediate though. Those particles can hang around for a couple of years and even circulate all around the globe. Nowadays, we've got special equipment to monitor sulfur dioxide emissions from space. Take Mount Pinatubo in the Philippines. During its eruption in 1991, it released around 15 million tons of sulfur dioxide. Now, while that's a lot, it wasn't quite as massive as the eruption of Tambora. Still, Pinatubo managed to lower global temperatures by about 0.5 degrees Celsius for several years. Tambora, on the other hand, dropped average global temperatures by about 1 degree Fahrenheit. I know what you might be thinking. That's not much, but trust me, it makes a difference. If the planet warms up by just 1 degree Fahrenheit, it could really mess with sea levels. Experts think we might see a rise of up to 8 inches by the end of this century. This could wipe out a lot of farmland and coastal habitats, which would be a huge blow to many communities. So maybe a volcano eruption that can cool off the planet is like a natural mechanism helping us out? Not exactly. While it does cool the planet off, don't get tricked into thinking it's the kind of coolness our planet needs. Such temperature shifts can severely mess up with the crops, like they did in 1816. There's also evidence that major eruptions can disrupt rainfall patterns, leading to drier conditions in monsoon regions across Africa and Asia. You see, the summer monsoon relies on the temperature difference between land and ocean, which can be altered by volcanic activity. Interestingly, a warmer climate may enhance the cooling effects of volcanic eruptions. Experts explain that the formation and movement of aerosol particles depend on climate conditions. As global temperatures rise, faster air circulation can lead to smaller aerosol particles, which are more effective at scattering sunlight and thereby intensifying the cooling effect. Oceans also contribute to this dynamic. A warming ocean surface creates a stratified layer, hindering the mixing of warm and cold water, which could mean that volcanic eruptions primarily cool the upper ocean layer and the atmosphere above it, according to Stoffel. Moreover, climate change may influence volcanic systems directly. The melting of ice can trigger more eruptions by reducing the pressure that allows magma to ascend more easily. Additionally, increased rainfall associated with climate change can seep into the ground and interact with magma, potentially sparking eruptions. While the prospect of a cooling period due to a volcanic eruption might seem beneficial amid climate change, scientists warn that the effects could be dire. The immediate consequences could be severe, particularly for the estimated 800 million individuals residing near active volcanoes. A major eruption could devastate entire cities. For example, Campi Flegrei, located near Naples, Italy, is showing signs of increased activity and threatens the lives of about 1 million people. Now, if you're from Oregon, beware, as experts say this state might experience volcano eruptions. Are you scared? Don't be. It's actually not as scary as it seems. Let me explain why. There are more than 80 volcanoes in Oregon, but we're not interested in a single one of them because it's an underwater volcano that is likely to erupt in 2025. Axial Seamount is the most active volcano in the Pacific Northwest, yet it remains largely unknown to the public due to its location approximately 300 miles offshore and nearly a mile beneath the ocean surface. While its upcoming eruption is expected to pose no threat of a tsunami or significant land-based earthquakes because of its depth and distance from the Cascadia Fault, the data gathered from studying its eruptions can enhance our monitoring of potentially more hazardous volcanoes. Let's call it a friendly eruption, shall we? In reality, predicting eruptions is a complex endeavor. We often encounter alarming headlines such as, "Yellowstone is about to erupt." Should we take these claims seriously? Not really. Yes, Yellowstone sits atop an active supervolcano that has experienced 3 major explosive eruptions in the past 2.1 million years. The last eruption occurred approximately 70,000 years ago, with the most significant explosion taking place around 631,000 years ago, forming the massive Yellowstone caldera. Naturally, many people are curious about whether Yellowstone will erupt again and when that might happen. Fortunately, scientists are employing new techniques to delve into these questions. A recent study suggests that Yellowstone is unlikely to experience another major eruption anytime soon. The reason is that the magma beneath the park is divided into a network of separate chambers. While there is a substantial amount of magma present, it's not sufficiently interconnected to support an eruption. Previous studies proposed that the existence of a massive layer of magma beneath Yellowstone, but these latest findings change that notion. To gain a clearer understanding of the subterranean dynamics, researchers utilized a technique called magnetotellurics, which employs Earth's natural electromagnetic fields rather than seismic waves. Since magma is a good conductor of electricity, this method is particularly effective for mapping molten rock and comprehending underground activity in volcanically active regions. By using magnetotellurics, scientists created a detailed map of the magma under Yellowstone, enabling them to make more informed predictions about future eruptions. But what will happen if an eruption similar to Mount Tambora occurs? By and large, there will be huge climate chaos. Yeah, the best scientists are looking for the solution should it really happen, but they don't have it yet. So technically, we're not ready for the second Mount Tambora. But for now, we're pretty much safe. No major eruptions are predicted. Whew!
It happened in Iceland on Friday, March 19, 2021 at 8:45 p.m. About 20 miles southwest of the capital. Molten rock suddenly burst through the surface from below. Bright lava fountains then lit up the night sky. A volcano in this valley finally woke up after almost 800 years of sleeping soundly. We divide volcanoes into three categories: active, dormant, or extinct. Around 1,900 of them around the globe are considered active. That means they've erupted in the recent past and will likely do it again in the possible near future. Dormant volcanoes haven't popped off for a long time, but they still may in the future. You could say they're sort of sleeping. As for extinct ones, those guys haven't done anything in more than 1 million years. The eruption in Iceland wasn't super explosive, and this all happened 6 miles from the nearest town, so everyone was perfectly safe. Many even came to see it up close, while other brave visitors tried to fry eggs and bacon on the lava. Just be careful not to burn your breakfast black. Lava can be over 2,000 degrees Fahrenheit. It burns everything in its path. Yet it also produces some of the most fertile land for agriculture. This eruption gave a relatively small amount of lava at first, but it's been spreading across the valley in different directions, forming a sort of shield that's constantly growing. You can never really predict how fast a lava flow will be until you see it. It all depends on how thick it is and how steep the mountain slope. Lava can ooze slowly at about 20 feet a minute, a fraction of the average person's walking speed. Or it can flow as fast as 30 miles per hour, which even the fastest person on Earth can't outrun. But the lava isn't even the most dangerous thing about volcanoes. That would be the toxic gases spewing from the eruption. And those spread faster and further than the lava flow. Luckily, in Iceland's case, the wind has been blowing these gases away from residential areas. Scientists weren't surprised this volcano erupted. They knew it was coming. Increasingly stronger earthquakes had been shaking this area for the past 15 months. There were 50,000 earthquakes within just the 3 weeks leading up to the eruption. That's 100 per hour. The volcano has been active since March, and geologists say this could last for weeks, months, years, or even decades of constant eruptions in the area. Mount Shasta is in the top 5 most dangerous volcanoes in the U.S., so geologists are keeping a close eye on it. The last eruption was in 1250. I wasn't around then, but this volcano erupts every 600 to 800 years. Which means tick-tock, we're due any day now. About an hour from Portland, Oregon, there's an active volcano that last erupted in the 19th century. Next time it goes off, scientists think it'll produce larger amounts of ash and dust. This could cause an electrical blackout and make water unsafe to drink in the area. But the experts pay close attention to Mount Hood. They'll be able to give plenty of warning so people can react in time. Kilauea is one of the most active volcanoes in the world. It's been erupting almost constantly since 1983. making it also one of the longest eruptions known on Earth. It's the youngest land volcano in Hawaii. Volcanoes can take thousands of years to form, but others can pop up practically overnight. A volcano in Mexico just erupted in an open field in 1943 and started growing from there. Within a year, it was almost 1,500 feet tall. When the eruptions finally stopped 9 years later, the mount had reached a height of over 9,200 feet. Mount Fuji is an iconic symbol of Japan. The last time it erupted was in 1707, and it sent a shower of burning rocks as far as 60 miles away. If a similar eruption happened today, Tokyo would be within that vicinity. Mount Fuji is right on the Ring of Fire, that horseshoe-shaped region in the Pacific Ocean full of active volcanoes and earthquakes. From one end to the other, it's almost 25,000 miles long. It could wrap all the way around the Earth's equator. In January 2020, Taal volcano in the Philippines started spewing lava, sending huge plumes of ash half a mile up into the sky. The eruption even triggered a rare phenomenon, a dirty thunderstorm. That's when the smoke cloud above a volcano produces its own lightning. The chance of volcanic tsunamis was also high. Those are usually caused by tectonic movements that occur because of volcanic activity. Taal has erupted more than 30 times in the last 450 years. This volcano in Ecuador last erupted in 2016. Scientists think it might be showing some early warning signs of magma on the move. This is an active stratovolcano, a specific cone-shaped type with steep sides. They form from sticky lava that doesn't flow that easily. That lava goes around the vent, cooling and piling on itself to form these steep walls. These types are more likely to produce explosive eruptions like the ones we see in movies. Ruapehu is the oldest national park in New Zealand, a volcanic wonderland where you can closely see all those steaming craters, magnificent lakes, and unusual rock formations. It last erupted in 2007 and has had 10 eruptions since the mid-19th century. But eruptions, lava flows, and toxic gases aren't the only danger coming from volcanoes. There's also a thing called lahar, a kind of volcanic mud flow of debris. In between eruptions, snow melts and a lake forms in the caldera. If the last eruption brought mud, ash, and rocks in the lake, it becomes dangerously full. In that case, only a temporary dam holds it back. Indonesia has the biggest number of active volcanoes in the world, including one called Anak Krakatoa. It means child of Krakatoa, and its famous parent isn't far away. A huge tsunami in 2018 partially woke Junior, a scary thought since Senior had one of the most powerful eruptions ever seen on this planet in 1883. Krakatoa's boom was the loudest sound ever heard. People over 2,000 miles away could hear the explosion. The sound wave circled the globe 7 times, and scientists say it's hard to predict this volcano's eruption patterns. Mount Yasur in Vanuatu is one of just a few volcanoes in the world where you can see a lava lake. Tourists even go there to peer over the edge and get a look at the burning, bubbling lake below. Well, except for when the volcanic activity goes to levels 3 and 4 out of 5. That means there are more intense earthquakes, volcanic tremors, or steam, gas, or ash ejections. Then this place is off limits because, duh. This volcano in the DR Congo has the most active and largest lake volcano in the world. And all that lava is unusually fluid, meaning it travels faster and further than the stuff coming out of most volcanoes. It's certainly not amongst the tallest ones, but Ethiopia's Erta Ali is unique in that it has a lava lake almost constantly, which is pretty rare. The locals call it a smoking mountain because its lava lake often causes eruptions. This volcano is near the Danakil Depression, one of the hottest places on our planet. Merupi has been erupting on a regular basis since the mid-16th century. This volcano helps scientists do crucial research on how eruptions work, and how they can warn people in time. After it was dormant for a while, this volcano in central Mexico sprang back to life in 1994. Ever since then, it's been producing huge mud flows and strong explosions in unpredictable intervals. In the past, enormous eruptions coming from this giant buried entire cities in pyramids. Imagine staying in a hotel and waking up to the magnificent view of a massive volcano covered in glowing rivers of lava and clouds of ash. When it lets off heat, visitors to this area in Guatemala take a chance to roast some marshmallows there. One of the most active volcanoes on Earth is on a small island north of Sicily. Stromboli has regular explosions, together with glowing lava coming from vents inside the crater. Not too far away is Etna, Europe's most active volcano and one of the biggest continental ones in the world. By the way, Earth definitely isn't the only planet with volcanoes. The largest one in our solar system is on Mars. It would cover the entire state of Arizona, and it rises nearly 3 times higher than Mount Everest. Ooh, don't look down. The ground beneath your feet holds the timeline of our planet. This is how we learn about Earth's past. But deep inside the Grand Canyon in Arizona, that timeline is broken, and records of billions of years are missing. Just poof. But it seems that scientists have finally solved exactly what kind of force could make billions of years old rocks disappear. Usually, our planet builds its history layer by layer. Sediment and tiny shells drift down to the seafloor, pile up, get buried, and harden into rock. Older layers stay down, newer ones stack on top. So the Grand Canyon should work like an easy-to-follow chronicle of what happened first, what happened next, and what came after that. One layer might come from an ancient river. Another might still show ripples from a sea that vanished long, long ago. Usually, the farther down you go, the older the rocks get. But in some places, that order suddenly breaks. Younger rock can sometimes end up resting directly on much older rock, with a stretch of time missing in between. Geologists call gaps like that unconformities. They can form when older rock gets exposed and worn away, or when new sediment stops piling up for a long time. What makes the Grand Canyon differ is the scale. In some spots, relatively young strata sit directly on basement rock about 1.7 billion years old. The gap can reach 1.2 billion years. Since Earth is 4.5 billion years old, that's roughly a quarter of Earth's history missing at the surface. And it's not just one neat break. The Grand Canyon has several major gaps in its rock record, and the biggest of them is often grouped under the label of the Great Unconformity. Now, a lot of that missing time falls in the Proterozoic era, the middle stretch of Earth's history. This was long before dinosaurs, trees, or even grass. The continents were mostly bare rock, meeting muddy coastlines. And almost all life was still tiny and ocean-bound. One of the clearest signs of that world was stromatolites, layered mounds built by microbial mats in shallow water. As these microbes trapped sediment over and over, the layers slowly built up into rock. Some stromatolites still exist today, which makes them one of our best glimpses into that older Earth. So, when rocks from this stretch of time get erased, we lose evidence of what early Earth looked like and how early life was changing it. Long before animals arrived, tiny ocean microbes transformed the planet. They triggered the Great Oxygenation Event. These microscopic organisms used sunlight for energy and pumped out oxygen as a byproduct. Slowly, that gas saturated the oceans and filled the atmosphere. This shift led to a long stretch of time scientists used to call the Boring Billion. From roughly 1.8 billion to 800 million years ago, the fossil record suddenly flatlines. But that era was actually a biological boom. Life was busy developing upgrades. Simple bacteria evolved into complex cells called eukaryotes. Organisms figured out sexual reproduction. Single cells finally teamed up to create the very first multi-celled life forms. The blueprints for every animal on Earth were being drawn up right in those oceans. So why did the record look so empty for so long? Because a lot of the physical evidence of those leaps may have been destroyed. Erasing a billion years of biology requires catastrophic damage. If we examine the Grand Canyon, the scrape is not small. Geologic models suggest up to 3 miles of solid rock got stripped away from the continents. That's almost 16,000 feet of ground, scooped away like with an ice cream spoon. Nature basically took a belt sander to the continents. Millions of years of rain chewed through solid granite like it was wet cardboard. Entire mountain ranges completely collapsed into mud. The weather shaved off 3 miles of solid crust until nothing survived except the deepest underground roots. When those peaks washed into the sea, they dragged the entire fossil record right along with them. So what happened? For a long time, the favorite theory was snowball Earth, a pair of extreme global freezes during the Cryogenian, between about 717 and 635 million years ago. It works like this. Ice reflects sunlight. When that light bounces back into space, the temperature drops. A cooler planet creates more ice. That expanding ice reflects even more heat. Once that loop starts, it's hard to stop. Glaciers kept growing until they swallowed the continents completely. If snowball Earth really looked like that, it would be like a strange planet, far from its star. We're talking about glaciers thousands of feet thick, creeping toward the equator. Those walls of ice acted like a bulldozer. Glaciers spread across the continents. They did not move fast, but they were heavy and unstoppable. Rocks trapped inside the ice got dragged along the ground, scraping, crackling, and grinding the land underneath. Some boulders were smashed into smaller pieces over time. At sea, thick ice covered areas of the ocean. Now normally, dark ocean water soaks up heat. Bright ice does the opposite. It reflects sunlight away, which cools the planet and helps the ice grow even stronger. So when all that crushed rock got washed into the ocean, it may have changed the chemistry of seawater in a big way. The ocean suddenly had far more material moving through them. Some scientists think that extra mineral input helped create better conditions for early animal life right before the Cambrian explosion around 541 million years ago. That's when shells, armor, eyes, and all kinds of body plans became much more common in the fossil record. But a 2026 study made the story even stranger. At great unconformity sites in northern China, much of the erosion seems far older than snowball Earth. The main phase appears to fall between about 2.1 and 1.6 billion years ago. That points directly to plate tectonics. Think of Earth's outer shell like a cracked, hard-boiled egg. Those puzzle pieces constantly drift around on top of molten rock. When two of those pieces slam together, the ground has nowhere to go but up. The crust violently bends. Peaks push straight into the sky. Once those rocks reach the clouds, weather instantly starts chewing them back down to flat ground. Scientists call this the supercontinent cycle. Imagine taking all the separate continents we have today and shoving them together into one mega-island. A supercontinent called Nuna formed exactly like this billions of years ago. Eventually, underground heat ripped that giant landmass apart. Think of a pizza. Ooh, pizza. If you leave it uncut, it only has a crust around the outside edge. If you slice it up and pull the pieces apart, every single slice suddenly gets its own edge. Breaking up a supercontinent creates thousands of miles of shallow coastal waters. These areas became safe zones for complex cells to multiply. Now, why would that matter for missing rocks? Because continents do not slide together quietly. They crash together like slow-moving freight trains. The ground buckles. Millions of tons of crust crumple upward. Mountain ranges rise miles into the air. Now that the rock sits exposed in the open sky, it is vulnerable to weather. Then there is Rodinia. This was another giant supercontinent that formed a bit later on. When Rodinia shattered into smaller pieces, it triggered a wild climate chain reaction. Heavy rains pounded the new rocks. That falling rainwater actually soaked up huge amounts of carbon dioxide directly from the air. The shattered rocks acted like a giant sponge, sucking up Earth's heat blanket. With less carbon dioxide to trap the sun's warmth, global temperatures absolutely plummeted. The planet quickly locked into a deep freeze. That's why many geologists no longer see the Great Unconformity as one clean cut made at one moment everywhere on Earth. In some places, tectonic collisions may have done most of the damage. In others, snowball Earth may have stripped away more. In some regions, both likely mattered. So the mystery has gotten bigger, not smaller. For years, planet-wide ice looked like the main suspect. Now, newer studies suggest some of the missing chapters may have started disappearing much earlier, during the rise of Earth's supercontinents. This may not be one missing page. It may be a whole chapter torn out and scattered across time. The prehistoric landmass Doggerland wasn't some empty wasteland during the last ice age, like scientists used to believe. It was alive, full of trees, animals, and maybe even people. And then the North Sea swallowed all of it like it never existed. So, no, Doggerland was not some ancient gigantic dog pound, although that would have been cool. It was a massive stretch of land that used to connect Great Britain to mainland Europe. You could have walked on it from modern-day England to the Netherlands without seeing water. Rivers cut through it, animals migrated across it, and early humans likely followed those same routes, finding prey, gathering, and building their lives on this land. Then, glaciers melted and sea levels began to rise. Doggerland was drowning slowly. Land turned into wetlands, and wetlands broke into islands. Islands shrank year by year. Forest paths turned into marshes, and rivers widened into channels. And eventually, somewhere between 10,000 and 7,000 years ago, the sea finished the job. But now, scientists have pulled out evidence of a full forest ecosystem that existed here over 16,000 years ago, thousands of years earlier than previously thought. They used sedimentary ancient DNA analysis to figure it out. Every living thing leaves behind tiny traces of itself, microscopic fragments of DNA, and those fragments can get trapped in mud and sand. Over thousands of years, layers build up, and those fragments stay there, like fingerprints pressed into wet cement. Scientists drill down, pull up those layers, and read them like a timeline. When they analyzed sedimentary ancient DNA from 252 samples from 41 marine sediment cores, they found traces of oak trees, elm, hazel, real temperate forest species. And they weren't just surviving there, but thriving more than 16,000 years ago. That's deep into the last ice age, a time we've always imagined as brutal and lifeless, especially in northern Europe. But instead of a frozen desert, it looks like this area was a hidden pocket of life. And this wasn't just a temporary burst of life after the ice, but a deep-rooted ecosystem. It was stable enough to support large trees with massive root systems. You don't get that unless the soil holds together, unless there are seasons, growth cycles, and enough balance for life to settle in and stay. Among all the DNA, scientists found traces of a tree called Pterocarya, a distant cousin of modern walnut trees. The weird part is that researchers believed it disappeared from that region around 400,000 years ago. But somehow, it held on here, and that detail changes how we understand extinction. It could mean that species don't always vanish completely. Sometimes they retreat, hide, and survive in small pockets we just haven't discovered yet. All this means that parts of Doggerland probably remained above water during major flooding events, like the Stagega tsunami around 8,150 years ago. This means this land didn't just vanish, it resisted. It broke apart slowly, holding on in fragments before it finally disappeared. But actually, all of that still exists. It's not alive or visible, but preserved under layers of seabed and miles of seawater. Ships pass over it every day. Waves roll across it. If you could somehow drain the North Sea for a moment, you would see those old river channels carved into the earth, soil layers, and maybe even preserved roots where trees once stood. Another cool detail is that scientists think Doggerland might explain why traces of early humans in Britain seem so scattered. If people lived there, and it's very likely they did, then when the sea swallowed the land, it swallowed their history with it. Campsites, tools, pathways, and entire communities were all gone. Now, Doggerland isn't some one-time anomaly, so let's jump to the extreme opposite. Antarctica, with its endless ice, brutal winds, and temperatures that don't forgive anything. You look at it and think nothing survives here. But scientists walked across it and proved that idea completely wrong. Between late 2019 and early 2020, a team trekked across a remote part of Antarctica. Their instruments picked up something strange under their feet. Not solid ice as they expected, but something softer. So they drilled. Layer after layer of ice came out. Until about 40 feet down, they hit something impossible: liquid water. It was a lake hidden under ice in one of the harshest environments on Earth. They tested the water, trying to understand where it came from. Because this place doesn't get much snowfall, the wind strips moisture away. Sunlight evaporates whatever little exists. So, how does a lake survive here? The answer is chemistry. Tiny traces of dissolved materials in the water help scientists find a hidden source. It turned out that a nearby glacier feeds the lake through underwater pathways no one knew existed. And then they looked closer and found microbial mats, living carpets made of microscopic organisms inside that dark sealed environment. Some stretch flat across the lake bed like rugs. Others grow upward in spiky shapes that rise up to about 15 inches tall. That's over a foot of life growing in total darkness, under thick ice, completely cut off from the outside world. And this life doesn't just exist, but organizes and changes over time. It's structured like a miniature forest floor, just in a completely unusual form. Another Antarctica discovery that shocked scientists was bubbles. They sit inside what might be the oldest ice ever brought up into daylight, nearly 1.2 million years old. Now, before this, researchers could only track Earth's climate history back about 800,000 years. That already felt ancient, but it still left a huge chunk of our planet's story missing. So scientists went looking for the right ice to fill in the gaps. Some parts of Antarctica actually hold ice that could be 3 or even 4 million years old, but it's messy and incomplete. They needed a clean timeline, layer after layer, year after year. So they spent years searching for that perfect spot, scanning the frozen continent like detectives looking for a buried archive. And when they finally drilled down into the ice at just the right location, they hit something special: crystal clear ice cores, stacked like a frozen timeline with tiny bubbles inside. Each one came with a microscopic sample of ancient air, sealed off from the world for hundreds of thousands, sometimes over 1 million years. When scientists study those bubbles, they can figure out what the atmosphere looked like, what gases filled the sky, how much carbon dioxide floated around, and how the planet's climate shifted over time. One moment locked inside that ice stands out more than most: the period around 900,000 years ago. That time might have been one of the closest calls our species ever faced. According to genetic studies, back then, the human population dropped to around 1,300 individuals worldwide. Nobody knows exactly what caused it, but climate is one of the biggest suspects. Massive environmental shifts, changing temperatures, unstable ecosystems, everything could have stacked against early humans at once. And those bubbles might hold clues to what kind of world those few survivors had to endure. So when scientists look inside one of those ancient bubbles, they're tracing survival. They're asking how a handful of humans made it through one of the toughest chapters in Earth's history, and what that might mean for us today. And when scientists scanned Antarctica from space, they found something even harder to wrap your head around. Beneath over 6,000 feet of ice, they detected an ancient landscape. Not rough shapes, but actual terrain with valleys carved by rivers and land split into blocks by tectonic forces millions of years ago. A place where water once flowed freely across the surface. This landscape dates back around 34 million years ago, to a time before Antarctica froze over completely. And somehow, in this one region, the ice didn't grind it away. It just sat on top of it, frozen in place, and preserved it like a time capsule. Scientists described it as a ghost, because it shouldn't still exist. Most landscapes get reshaped, erased, recycled by Earth over time, but this one just stayed. When you connect all of this, you can see that Earth doesn't change slowly and predictably. It hides things like entire ecosystems and histories. We walk around thinking we know this planet, but underneath us, under oceans and ice and layers of time, there are entire worlds we haven't even touched yet. Kilauea, one of the most active volcanoes in the world, erupted again in March 2026 on Hawaii's Big Island. Huge lava fountains shot into the sky. The main highway was closed, and the airport was blocked by sandpaper clouds of ash. The sky turned a creepy deep red. That's how thick the smoke was. The eruption literally closed some areas of the island. It was already the second time this year. The eruption happened right inside the Halemu'umu'u crater at the volcano summit. Things got dangerous fast, and visitors had to evacuate the volcano summit. The lava fountain shot straight up about 1,300 feet. That's almost as tall as the Empire State Building or higher than the Eiffel Tower. But let's watch the eruption unfold step by step. It started on March 10, 2026, and lasted about 9 hours, ending suddenly at 6:21 p.m. The eruption started in the morning at 9:17, with lava shooting up from the north vent. As for the south vent, it started erupting just before 10 a.m. By early afternoon, the lava fountains were huge. The south vent reached 1,150 feet high, and the north vent was 1,000 feet. The lava was flowing across about 1/3 of the crater floor, glowing bright orange and red. As the lava cooled in the air, it turned into something called tephra. That's a mix of volcanic rock, ash, and tiny glassy shards. Tephra can scratch your skin like sandpaper, making your eyes sting and making it hard to breathe. Even worse, it can turn roads into skating rinks for cars. Because all of this, part of Highway 11 was closed between mile markers 24 and 40. Back in January, during another eruption, it also rained tephra over the park and nearby towns. Some unlucky visitors actually got hit by falling tephra, and a few even got cuts. The Park Service had to close the summit for the first time since its eruption cycle began on December 23, 2024. Now, the National Weather Service says the eruption plume reached 25,000 feet high. That's nearly 5 miles straight up, higher than most airplanes fly. Winds were blowing from the south, so ash and gas started moving north from Halemu'umu'u. Officials warned people in nearby cities to stay indoors or leave if the gases began to bother them. Now, this eruption wasn't the first trouble Kilauea caused this year. An earlier one started on February 15th and lasted almost 10 hours. During that eruption, lava covered half of the crater floor. Scientists estimate that 15 million cubic yards of lava came out. That's enough to fill thousands of swimming pools or cover hundreds of football fields. At 2 p.m. on March 10th, tephra was still falling. Park rangers helped evacuate visitors from the summit. All trails and viewing spots near the summit were closed. Scientists are keeping an eye on things all day and night, watching how high the lava shoots, how fast it flows, which way the ash cloud is moving, and where the fallout spreads. Even though the lava mostly stays in the crater, tephra and volcanic gases can make living near a volcano pretty risky. Since December 24, 2024, Kilauea has been spitting lava on and off, mostly from 2 vents at the summit crater, one to the north, one to the south. Eruptions happen in short bursts, usually less than half a day. After that, the volcano takes a break for a while. Could we say the volcano is chilling? No, we can't. Sometimes those pauses can last 2 weeks or more, as if giving the lava time to catch its breath before the next show. But let's talk a little bit more about tephra. The biggest problem is that it doesn't just stay near the volcano. In past eruptions, it rained down on neighborhoods as far away as Hilo and Puna, messing up water systems and creating a huge cleanup job. At Hilo International Airport, all evening flights were canceled because of ash in the air. And for weeks afterward, locals and park staff were sweeping tephra off roofs, gutters, streets, just about everywhere you can imagine. According to the park spokesman, the reason tephra spread so far is a mix of weak winds and extremely tall lava fountains. When that happens, the volcanic debris drops straight down over the park and nearby towns. During past eruptions, steady winds, called trade winds, which usually blow from east to west across the islands, acted like a conveyor belt. They carried ash and volcanic gases over the Cow Desert and nearby towns to the southwest. Another super dangerous thing about an eruption is glass rain, also called Pele's hair. It's a kind of tephra that happens especially when lava fountains shoot up really fast. Tiny gas bubbles in the lava burst and stretch the molten rock into super thin, fragile strands. The wind then carries them far away. This stuff is lightweight but brittle, so it can scratch your skin or get in your eyes or lungs. The name comes from Pele, the Hawaiian goddess of fire and volcanoes, because it's kind of born straight from volcanic activity. During big eruptions, like the one in 2018, these strands were reported falling all around the volcano. Now, Kilauea isn't the only threat in the region. The sleeping giant next door, Mauna Loa, got an update from scientists on March 5, 2016. The volcano isn't erupting yet, but it's inflating as magma fills its huge underground chambers. You might think of it like Earth taking a deep breath. But it isn't just breathing. In the past month alone, over 100 earthquakes have been detected under the summit. Should we get worried? Well, let's figure it out. Mauna Loa, the largest active volcano on Earth, covers half of Hawaii's Big Island. Its eruptions can produce huge, fast-moving rivers of lava, like a slow-mo bulldozer made of molten rock moving across the area. When Mauna Loa erupts, it usually starts at the summit. From there, lava can flow into different areas: the Northeast Rift Zone, Southwest Rift Zone, or even vents on the northwest side of the volcano. The most intriguing thing is that these lava flows can appear within minutes, hours, or even months after the eruption begins. Since its first well-recorded eruption in 1843, Mauna Loa has erupted 34 times. The gaps between eruptions can range from just months to many decades. Its most recent eruption was in 2022. Right now, Mauna Loa is quiet but active. Seismic activity, that is, small earthquakes under the volcano, shows that magma is, in fact, moving beneath the surface. In February 2026, scientists detected 116 earthquakes beneath the summit, mostly gathered under the caldera era called Makuaweo Veo. Some were also concentrated in the southern caldera. But don't let this number scare you. For comparison, the month before had 123 earthquakes. The thing is, these quakes are part of the normal breathing of the volcano as it refills with magma after the 2022 eruption. GPS instruments on the volcano indeed show that the summit is inflating, meaning the ground is slowly rising as magma fills the underground reservoir. At the same time, gas and temperature readings from the southwest rift zone are at normal levels, which means no major changes compared to previous months. So even though Mauna Loa is refilling, there's no immediate sign of a new eruption, yet. In any case, Mauna Loa is always worth watching. It's a sleeping giant that can wake at any time, and scientists are keeping a close eye on every inch of rising ground. Because if Mauna Loa erupts, it can cause a ton of different problems. Massive rivers of lava can flow quickly and cover land in their path. The volcano itself can also make the ground shake. because as magma fills it, the sides of the mountain can shift up or sideways, triggering earthquakes. On top of that, Mauna Loa can release volcanic gases that mix with the air and create fog, a kind of smog that can be irritating or even make it hard to breathe for people living downwind. Sometimes, the volcano might even produce small explosions, sending ash into the sky, which can be dangerous for airplanes flying nearby. In 2015, a volcano erupted, and the seafloor dropped about 8 feet, like an elevator giving up mid-ride. By then, scientists had already put wires and sensors all over the place. The idea here was simple. Since it erupted fairly often, they wanted to predict the next disaster, and they sorta did. They circled 2025 in red and waited. Except, nothing happened. But the ground is still swelling and quaking almost daily, and now everyone is worried. Let's see why. Axial Seamount is a volcano about 300 miles off the Oregon coast. But to really find it, you would need to dive almost a full mile. You'll also find something unexpected there – yellow cables, miles of them. This is one of the most watched volcanoes on the planet. Through a massive project called the Ocean Observatories Initiative, or OOI, scientists draped the underwater mountain in 550 miles of fiber optic cable. Sadly, it's an observatory in name only, serving more as a science experiment than a proper observatory. There's no cool-looking dome where people live and research underwater. These cables power a massive network of sensors. They count earthquakes, track the ground rising by fractions of an inch, and listen to the magma rumble. These sensors are so sensitive that they can feel the moon. When the tides rise, the extra water presses down on the volcano and sets off tiny earthquakes. To put this all in place, they had to use remote-controlled robots that dove down and physically plugged those sensors into the network. Plugging a TV into an extension cable in a dark room is hard. Now imagine doing that 4,600 feet under the surface. You're using a robot arm, and the pressure is strong enough to crush a small pickup truck. But why go through all this trouble? Volcanoes are lazy. Most sleep for centuries. Some wake up once, flood half a continent with ash, and then go quiet for hundreds of millions of years. If you study volcanoes, you might wait your entire career and never see a single drop of lava. But Axial sits right where two tectonic plates are ripping apart. Magma is constantly refueling the tank. It's not the type that needs to wait hundreds of years to recharge. It can erupt every decade or so. Now, it doesn't blow its top like Mount St. Helens. There's no earth-shattering kaboom. Instead, the ground swells up, cracks open, and lava pours out quietly to create new rock. When the floor cracks, it blasts out a massive cloud of superheated water called megaplume that's packed with subsurface bacteria. It rises thousands of feet high and looks like a blizzard of white snow shooting through the dark ocean. Each eruption basically resets the biome, forcing life in the area to start over. That combination, frequent and calm, makes it perfect for study. It erupts often enough that we can actually collect data, and is predictable enough that we can build a model around it. By 2014, the observatory had already been in place, just in time for the eruption that happened in 2015. Scientists caught the whole event live. They had sensors on the seafloor that showed the ground puffing up like a giant balloon as melted rock gathered underneath. The ground rose up several feet until the pressure made the rock start to crack. This caused thousands of tiny earthquakes in just one afternoon. Then, miles-long cracks ripped open and lava poured out. As that magma leaked out, the ground lost its support. Eventually, the seafloor inside the volcano's crater collapsed. The whole point of capturing 2015 was to build a baseline. This is what right before an eruption looks like. So when the crater floor started rising again and the quake counts climbed, scientists figured Axial was heading toward another eruption in 2025. And then, nothing. Nada. Zippo. The signals reached the same zone that worked last time, but there was no eruption. It's like pumping air into a tire until it should blow, and it doesn't. So what went wrong for the researchers expecting a quiet explosion? What likely happened is that the volcano stalled. In 2015, the ground rose quickly, but nature likely changed the tempo. Magma is still filling the chamber, but it's pumping in slower than it did 10 years ago. It's also possible that the rock is stronger now, holding cracks better, forcing the volcano to swell even more. Now, there's also a third option, a quiet leak. Tiny fractures could be hissing out just enough pressure to delay the main event, keeping the volcano in a state of suspended animation, ready to blow but lacking the spark. And even with all the data, it's still hard to tell the difference between almost ready and about to break. That's why the forecast slid from 2025 to mid to late 2026. The volcano stayed active, but the buildup slowed, pushing the breaking point back by about a year. But why is this making scientists nervous? When you hear about the consequences of eruptions, it's easy to imagine a tsunami heading for the coast. Well, it's not. You can keep your surfboard in the garage. This is a deep ocean event. The water absorbs almost all the energy. The surface might get a little bubbly, but nobody on the beach is going to spill their drink. The people sweating are the ones who paid for the robots. The problem is that the lab is sitting inside a test tube. Remember, the volcano is currently overcharged. It has already swelled past the point where it usually pops. If it waits until late 2026 to finally let go, it could have accumulated significantly more magma than it did in 2015. A bigger eruption means new, cool data, but it also means a much larger volume of lava. Those expensive yellow cables and delicate sensors, they're sitting right in the splash zone. If the lava follows the old paths, the gear is fine. But an overpressurized release could rip open new cracks in the seafloor. If that happens, researchers could lose millions of dollars of equipment in seconds. Scientists might be watching the feed live, see a wall of molten glass, and then static. But the real worry isn't the money. Axial is supposed to be the gold standard. It's the most monitored square mile of the ocean floor on Earth. It was supposed to be the easy one. If our prediction model fails here, well, it's a bad sign. We have every sensor imaginable, and we still don't understand underwater volcanoes as well as we thought. If we can't predict the friendly volcano when it's wired for sound, what chance do we have with the dangerous ones? The vents around the volcano pump out water that could reach around 650 degrees Fahrenheit. On the surface, that would instantly turn to steam. Down here, the pressure is so intense that the water can't boil. But it's so hot it can dissolve minerals. The place is also loud. If you could hear it, it would sound like a jet engine on a runway. Plus, the area is carpeted in tube worms. They look like giant 6-foot-tall white pipes with bright red tips. They don't make biological sense. They have no eyes, no mouths, and no stomachs. They don't eat food at all. Instead, they host bacteria inside their bodies that turn the volcano's toxic sulfur gas into sugar. They're basically powered by pollution. Crawling all over them are scale worms. These things look like they belong on some other planet. They're covered in microscopic scales that refract light. So if you shine a flashlight on them, you could see them sparkle in blue and red. The ground beneath them is also strange. When axial erupts, the lava hits the freezing seawater and cools instantly. But it doesn't turn to gray stone. It turns into glass. Pure black obsidian. If you tried to walk on it, it would sound like you were walking on thousands of light bulbs. Experts have updated the schedule for this year. Cameras are in place to take some cool pictures, and we might even get a live stream on YouTube, watching the ground tearing open under the ocean. Let's just hope that it isn't the final broadcast. It's really hard to stream the next one if your multi-million-dollar camera ends up digested by a river of molten glass. I'll say. If you pull up a map, here, let me do that for you. The Strait of Gibraltar looks almost laughably narrow. At its tightest point, Europe and Africa sit just about 9 miles apart. You could technically kayak that on a calm day, if only it wasn't highly dangerous. Now, engineers want to punch through rock, pressure, and moving continents to turn that ancient divide into a boring 30-minute commute. And it's going to take a lot of boring. Yeah, that's a joke. But wait, why go through all that trouble and not just connect Europe and Africa with a bridge? Well, the biggest problem is the Strait of Gibraltar itself. The water here moves fast. The currents rank among the strongest on the planet. Plus, the strait is exactly where the African and Eurasian tectonic plates meet. The African plate keeps creeping northward, slowly squeezing toward Europe. It moves ridiculously slowly, just a few inches a year, so no one is going to wake up tomorrow and stroll across. Scientists built a detailed 3D model of the region, and it shows that in about 20 years, the strait could finally close and turn into the Isthmus of Gibraltar, basically a land bridge between the continents. But why wait millions of years? Plus, right now, that slow plate movement still causes real-world trouble. When those massive slabs of rock grind against each other, they build up pressure. That pressure releases itself as earthquakes, tiny fractures, and sudden shifts in the ground under the sea. Nothing down there stays perfectly still. Even if someone managed to build a bridge, powerful streams could shake the structure non-stop and tear joints apart, unless designers created an insanely strong system. And that kind of engineering would eat unbelievable amounts of money and resources. If that's not enough, there's the depth problem. We're talking about almost 3,000 feet. That's one of the deepest straits on Earth. Any pile there would need insane length and strength, probably built from several massive sections bolted together. And even after installing them, earthquakes could still snap everything apart while currents drag pieces across the sea. But the most serious issue involves nature. The water here has a high salt content, which makes it heavier. That heavy salt water sinks into the Mediterranean basin and pushes colder water back toward the Atlantic. These movements create swirling currents, turbulence, and underwater boiling zones full of nutrients. That chaos feeds phytoplankton, tiny organisms that sit at the bottom of the entire marine food chain. Whales and fish absolutely love it there. The strange shapes of the seabed and the sunlight hitting different layers of water create perfect living conditions. If construction started, there would be dust, crushed rock, carbon dioxide, fuel, and falling materials. All of it would cloud the water and ruin the natural food chain. That's why a tunnel sounds like a better idea. Spain first proposed to build a modern tunnel here in 1930, but it was impossible to drill through hard rock with the technology they had at that time. But then, in December 2003, Spain, this time together with Morocco, decided to go back to the idea and build a tunnel that would connect the rail systems of the two countries. It took them another 20 years to start designing and planning the tunnel. Now, construction is scheduled to start in 2030 and will take around 10 years. This tunnel will need to be a true engineering marvel that will live with the motion of tectonic plates, not go against it. The structure will need flexibility, shock resistance, and a safety margin for movements that no one can perfectly predict. So, according to the new project, the tunnel would plunge down to more than 1,000 feet below sea level at its deepest point. That makes it about 6 times deeper than the Channel Tunnel between England and France. Now, length matters too. The full tunnel would stretch close to 25 miles, with roughly 17 miles directly beneath the seabed. Once you're in the middle, you're farther from open air than most people will ever be in their lives. It means no quick exits or easy rescues. Everything has to work perfectly. Ventilation, power, signaling, because there's no backup plan called just open a door. If it does work out, high-speed trains could carry passengers and freight from Spain to Morocco in about 30 minutes, something close to a regular subway ride. And that's not just convenience. That's a rewiring of trade routes, labor movement, tourism, and economic gravity between continents. More than 12 million people could travel on that route every year. Now, the design won't rely on one, but 2 parallel twin rail tunnels, one for each direction, plus service and emergency corridors in between. All of this will cost around $10 billion. And engineers will need to design something flexible enough to bend, absorb, and survive slow continental drift and constant pressure. The tunnel won't go against Earth. It will ride with it, like a shock absorber built into the planet itself. And this idea doesn't come out of nowhere, as humans have already built impressive underwater tunnels. The Channel Tunnel, the most famous example, already turned 30 in 2024. It runs under the English Channel, linking England and France. Trains can zoom through it in about 30 minutes, hitting around 99 miles an hour, and it's the longest underwater tunnel in the world as of now. 3 tunnels are running parallel under the seabed. 2 of them carry trains, one in each direction, and the third is a service tunnel in the middle used for maintenance access, evacuation, ventilation, and just general support. The whole thing was privately funded and crazy expensive. It went over budget, and while it eventually turned a profit, it hasn't been the financial goldmine people hoped for. Despite that, engineers still consider it one of the most impressive feats of modern civil engineering. And they even connected continents underwater before. Istanbul's Eurasia Tunnel has a 3.3-mile section that goes straight under the water. It links Europe and Asia by road in about 15 minutes. What once took nearly 2 hours now feels routine. The tunnel took 55 months to build and cost $1.3 billion. They had to reorganize traffic for it to make the access roads of the best quality. And the tunnel didn't just connect continents, but also helped reduce atmospheric and acoustic pollution in the city. Right next to it, the Marmara Rail Tunnel slides trains beneath the same strait, carrying commuters between continents like it's no big deal. These tunnels sit in an earthquake zone under shipping lanes, beneath constant currents, and they work. Once you see those projects, the Gibraltar Tunnel stops sounding insane and starts sounding possible, maybe even inevitable. Which naturally leads us to the most dangerous thought humans ever have. If we can do that, what else can we connect? Well, that's where the dream goes full sci-fi. People imagine stepping onto a train in New York and stepping off in London less than an hour later. No jet lag, no turbulence, just a straight shot beneath the Atlantic. Some proposals throw around numbers like 54 minutes, but that speed requires vacuum trains moving around 5,000 miles per hour. That technology doesn't exist outside of lab concepts and computer models, yet. Now, even if we ditch the sci-fi speed and use conventional rail, the trip would take roughly 15 hours, slower than an 8-hour flight. Then comes the real nightmare. The Atlantic is 12,000 feet deep on average, with pressure, geology, and distances that make Gibraltar look like a backyard project. Engineers would face earthquakes, underwater mountains, volcanic zones, and even finding a leak would feel impossible. Fixing it would be next level. The energy costs alone would make today's mega projects look cheap. That's why right now, a transatlantic tunnel lives in the same category as warp drives and cities on Mars. Inspiring, useful for pushing ideas forward, but not something you break ground on next year. The Gibraltar Tunnel, though, sits right on the edge of that line between impossible and inevitable. What once separated civilizations now tempts us as a corridor. What once seemed impossible now connects continents.